Hey guys, welcome back. Today we're going to look at some review sheet problems. I tried to just choose kind of a random smattering of some of the problems on here, especially ones that involve justifications. Okay, so I want to focus on question 3 here, parts A and B. So what we have is a table above us that was given in the prompt. If we look at the x values in this table, we see that they increase by the same amount each time. So we've got equal subdivisions here. And what they tell us is f of x is a differentiable function and is concave down. So when you see that concave down part, go ahead and underline that just so we, that may not come up in the first problem you do, but it'll eventually come up in one of the problems that you need to do. Okay. My screen's a little wonky. All right, there we go. And the concave down part ends up not really being part of anything until question 3. So the first thing I'm going to do is I'm going to answer 3a. It says estimate the integral from 4 to 16 of f of x dx using n equals 4 equal subintervals and a trapezoidal sum. So again, we want to underline that trapezoidal sum. That's the sum that we're going to do. Notice in questions 1 and 2, I didn't ask you if those estimates were over or under estimates. Because the function isn't increasing or decreasing. We can tell by the numbers, at times this function must increase, at times this function must be decreasing. So I can't tell if 1 and 2 are over or under estimates, but I can tell part 3 on a trapezoidal sum, because trapezoidal over or under estimates are determined by concavity. Okay, so first off, we have 4 equal subintervals from 4 to 16, right? We can do b minus a over n, 16, since they're equal subintervals. 16 minus 4 is 12. 12 divided by 4 is 3. So our subintervals are a width of 3. Again, I like to put those up here. 1, 2, 3, 4. All right, so I know a trapezoidal sum. I take the width of the subinterval, and then I average the two heights. So again, I'm going to use good notation here. I'm going to say the integral from 4 to 16 of f of x dx approximately equals, because it's an estimate. So the width of the first subinterval is 3. And again, I want to average the two heights, 7 plus 11 over 2. So that's the area of the first trapezoid, and I got 3 more to go. They all are going to have a width of 3. When I see this now, there's a variety of ways I can do this. Since I see a 3 is in every single term here, I'm welcome to factor out that 3 and just add up all of the averages. So that's what I'm going to do here to solve this, just to make it a little bit easier on myself. Okay, the first average is 7 plus 11 over 2. 7 plus 11 is 18. 18 divided by 2 is 9. 11 plus 13 divided by 2, right? That's 24 over 2 is 12. 13 plus 9 is 22. 22 over 2 is 11. 9 plus 3 is 12. 12 divided by 2 is 6. And since I was multiplying by 3 by all of those, I just factor that 3 out. And I just make the math a little bit easier to do here. 9 plus 11 then, right? I can add in any order I want. 11 and 9 are nice because they add to 20. So those two add to 20. 12 and 6 add to 18. 20 plus 18 is 38. Then I'll just do 38 times 3. That's 24. 3 times 3 is 9, plus 2 is 11. So I get an answer of 114. Okay. Notice I took some steps there to make my approximation that much easier to do. Okay, but here's kind of the question I'm more interested in, which is this an overestimate or an underestimate? Justify. Okay, this is when we need to understand, right? Whenever they ask you this, go back to the prompt, right, and see, oh yeah, I underlined that this thing is concave down. Concavity is going to tell me whether or not a trapezoidal sum is an over or an underestimate. And again, what I can do is just sketch a concave down graph, and I'll put in one of my subintervals here and one up here. And when I connect that to make a trapezoid, I can clearly see that I'm underestimating the value here. Okay, now what I saw a couple people do, so I saw a couple people when they sketched a concave down graph, they sketch something like that. Okay, that's not very helpful for you because it's going to be hard for me to draw a trapezoid in there and see whether a trapezoid sum is going to be an over or underestimate. So make it decent sized and make your subintervals wide enough where it's easy to tell if it's an over or underestimate. Okay, now to justify this, I can't just say it's an underestimate because the function's concave down. I have to tell about the concavity, but I also have to mention that I'm doing a trapezoidal sum here. I'm going to say 114 is an underestimate because after this concave down, and I did a trapezoidal sum. Okay. So make sure that you mention both the concave down part and the fact that you did a trapezoidal sum. Okay. So let's go to the next problem I wanted to look at was problem number 5. Let me just move this over. Okay, so problem 5 here says we have a table here. I notice now that my t values are not evenly spaced. The first one is a width of 2, the second one is a width of 3, the third one is a width of 5. So I can't do the trick that I did in the last one and just factor out a 3 because they're not equally spaced. Okay, and I just take a look at the units. T is in hours, R of t is in centimeters per hour. So I know R must be some kind of rate. And what it says is the table above shows selected values of R of t, the rate of snowfall during a snowstorm in Minneapolis, given in centimeters per hour. So R of t is measured in centimeters per hour. It says that twice in the table and in the prompt. Then it also says R of t is a differentiable. Right? That's important for when we do like our theorems. Right? We can do mean value theorem. We can do intermediate value theorem. Doesn't really come up in this particular problem. But it also says R of t is an increasing function. That's going to be helpful for me. I'm going to go ahead and underline that increasing function part. Okay, part A here is a 2-part question, and you need to answer both parts. The AP exam does this a lot, okay, and it's important that sometimes students just answer the first part of A and just move on to B before fully answering the question. So here's what it says. Estimate the integral from 0 to 10 of R of t dt using a Wright-Riemann sum. Okay, this is just the calculation part. This part is usually pretty easy for people, but we just want to make sure we do it right. Okay, this is a Wright-Riemann sum. And it says using the 3 subintervals indicated by the table. So I see here's my first one, my second one, and my third one. We're going to go ahead and solve this now, but I'm not going to forget about the second part of this question, which is using correct units, interpret the meaning of the integral from 0 to 10 of R of t dt in the context of the problem. That's, in my opinion, a tougher question to answer, okay, and requires just a different kind of thinking. But let's do our right Riemann sum first. Okay, so I'm doing a right Riemann sum. So I take my width. My first width is 2, and I multiply by the right number, which is 2.5. Plus, my next width is a width of 3, right? 5 minus 2 is 3, times the right number, which is 3. Plus, the final width is 5, and the right number is 5.5. And again, I should have 1, 2, 3 terms added together here because I have 3 subintervals. Okay, now 2 times 2.5, I just know that that's 5. 3 times 3 is 9. 5.5 times 5, I'm going to just double check that. Okay, and since I have a decimal in my long multiplication, I have 1 decimal place here. So I need to move my decimal point 1 time here. So I get 27.5. Okay. Now adding those up, I'm going to add 14, the 9 and the 5, plus 27.5. 0 plus 5 is 5. 4 plus 7 is 11. 1 plus 1 is 2, plus 2 is 4. So I get 41.5. Okay. In my unit now, if you think about this, we're taking centimeters per hour times hour. Centimeter per hour times hour is going to give us an answer of centimeters. Okay. So we can do that kind of unit analysis there, or you can just say, hey, this is a rate. When I integrate a rate, I'm going to get a total amount. Okay, that's going to help me with the second part of this question. So 41.5 centimeters is my answer, but then I have to answer the second part. Using correct units, interpret the meaning of 0 to 10, of the integral 0 to 10 of r of t dt in the context of the problem. So since r is the rate that snow falls during a snowstorm, the integral of that would give you the total amount of snow that fell during that time period, 0 to 10 hours. Okay, that's the kind of the harder part usually for students to see. So I'm going to write that out. I'm going to say the integral from 0 to 10 of r of t dt gives the total amount of snowfall in centimeters, right? That's the using the correct units part during the snowstorm. But again, whenever you're asked to explain a definite integral, make sure you talk about these two numbers. We have to talk about those two numbers as well. From t equals 0 hours to t equals 10 hours. Okay. Another way you can say that is in the first 10 hours of the snowstorm. Okay. We can get specific and say it's the amount of snowfall in centimeters in Minneapolis, right? Because the context is about Minneapolis. But again, anytime we integrate a rate, it's going to give us the total amount, and we just have to think about what the context of the problem is. Okay, so make sure you have both parts in there. When I was walking around yesterday, a lot of people only had the first part and not the second part. Okay, and then the second question is your estimate in part A an overestimate or underestimate? Justify. Okay, now we're going back to the fact that this function was increasing. Right-hand and left-hand Riemann sums, we determine whether it's an over or underestimate by whether or not the function is increasing or not. So I know r is increasing, so I'm just going to do a little sketch here. So here's an increasing function. When I put in my subintervals, I'm using the right side of the interval to make my rectangles. So for this subinterval right here, I'm using the right side. For this subinterval right here, I'm using the right side. When I see this, it's pretty obvious to tell that I'm going to have an overestimate. But once again, in our justification, we need to mention not just the fact that the function is increasing, but also that I did a right Riemann sum. I'm going to say 41.5 is an overestimate because R of t is increasing, and I did a right Riemann sum. You can also kind of figure that out by thinking about if I had done a left Riemann sum, I would have been using a smaller number for each of those widths. So I would have gotten a smaller number. So we were always using the bigger of the two numbers, so it made sense that this was going to end up being an overestimate. Okay, let's look at another one. Okay, here we see it just says evaluate integral 4 to 25 of 4 over root x dx. Okay, so this is called a definite integral because we have the numbers 4 and 25. Anytime we solve one of these, we want to make sure we want to solve it out to a numerical answer. So what we're going to do is we're going to do the antiderivative, then we're going to plug in 25, and then we're going to plug in 4, and we're going to subtract those two to get our final answer. So the first thing I have to do is I have to get this thing ready to do an antiderivative. Right now it's not in ax to the n form. So I'm going to rewrite this thing, not with brackets, but still with the integral sign. And I know that square root means half power, but I also have to address the fact that it's in the denominator. So I'm going to move that half power up to the numerator and convert it to a negative half power. Notice all I did was rewrite. I didn't actually do the antiderivative yet. That's why I still have my integral sign. Now I'm ready to do the antiderivative. So now the next one I'm going to run brackets. So the first thing I'm going to do is bump my power by 1. Negative half plus 1. Again, if you don't see that, think of it as 1 over 1, or better, 2 over 2. To have a common denominator, negative 1 plus 2 is 1 over 2, which is 1/2. And now I need to take my coefficient 4 and divide by half. But instead of thinking of it as 4 divided by 1/2, I want to think of it as 4 times 2 over 1. 4 times 2 is 8. And again, before I do anything else, I want to stop and make sure. Is 8x to the 1/2, is its derivative? Its derivative should be 4x to the negative half. Just do the derivative quick. Half times 8 is 4. X reduced by 1 would be negative half. 4x to the negative half. Check yourself there so you don't have to erase a whole bunch of work that you did. Okay, and I'm going to do one more rewrite here before I get the final answer, because in terms of evaluating, it's easier for me to evaluate with things like square roots than it is with rational exponents. So x to the half means square root x. I'm just going to make that rewrite there. So now I can plug in, and I'm going to have 8 root 25 minus 8 root 4. Okay. So root 25 I know is 5, right? I'm just, again, plugging in the top number for x, plugging in the bottom number for x, and subtracting them. Root 25 is 5. 8 times 5 is 40. Root 4 is 2. 8 times 2 is 16. And 40 minus 16 is 24. My correct final answer. Okay, let's look at another one. Okay, in this problem, what you'll notice is that there are no numbers here. That means this is an indefinite integral, which means to solve this one, I just want to find the antiderivative plus c. My answer should be like a function rather than a numerical answer. Okay, this is just a polynomial, so I'm going to use my bump and divide. It's all ready to go in ax to the n form. So the first one, I'm going to bump the power up by 1 to 4. And I'm going to divide my coefficient of 4 by my new exponent of 4. 4 divided by 4 is 1, so I'm just going to leave it as x to the 4th. Okay. I'm going to bump the power up to 3 and divide by 3. So I'm going to get negative 2/3 x cubed. And then when I have a constant, I'm going to multiply in that x. And again, just take a look right here. The derivative of x to the 4th is 4x cubed. The derivative of negative 2/3 x cubed is negative 2x squared. The derivative of negative 5x is 5. It's negative 5. Okay. But I have to account for there are many, many, many antiderivatives here. And I could have a constant added on at the end, so I'm just going to say plus c at the very end. Okay, and here's my final answer. Okay. And I think I have one more, the last problem. Is f of x equals 3 root x. Find the average value of f on the interval 1, 4. Okay? So I have to know my average value of f equation. That equation is 1 over b minus a, integral a to b of f of x dx. Okay? I'm going to identify 1 as my a, and I'm going to identify 4 as my b, and my function is 3 root x. So I'm going to start this thing by saying 1 over b minus a, which would be 4 minus 1, integral from a to b, so from 1 to 4, of my function 3 root x. But since I'm going to perform this definite integral, I want to go ahead and get it ready in ax to the n form. That root x, I'm going to convert to x to the 1/2. So I'm going to say 3x to the 1/2. Now, this 1/3 that's out front, I do not want to forget about that throughout this whole problem. Okay, so every time I'm rewriting this and solving this thing, the first thing I'm going to do is write that 1/3 so I don't forget about it. Okay? So now it's ready to do the antiderivative. So I'm going to say 1/3 bracket. I'm going to bump my power up by 1. I have half plus 1, or 2 over 2, which makes 3/2. And I'm going to take my coefficient 3 and divide by 3/2. But instead of dividing by 3/2, I'm going to multiply by 2/3. When I multiply by 2/3, I get 2 out. Okay? And again, I want to put this in a form that's going to be easy to evaluate. So I'm going to change this 3/2 power to a square root and then cubed. So again, I'm going to have 1/3 to square root of x cubed. Okay, and again, I keep writing my 1/3. And in fact, we talked about throwing the constant out front. You can do that here, and you can pull that 2 out, and 2 times 1/3 would be 2/3. So you're welcome to keep your 2/3 out front if you want, or you can keep it in there. It'll give you the same solution. I'll keep it in there, but I'll show you what it would look like pulled out as well. So I'm going to have 2 square root of 4 cubed minus 2 square root of 1 cubed. Okay. This Square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16. Square root of 1 is 1. 1 cubed is 1. 1 times 2 is 2. So I'm going to get a third of 14, which I can just write as 14 thirds. Okay. If I would have pulled that 2 out ahead of time, it would have looked something like this. Okay. I can do this if it just makes it easier on myself. I'm certainly welcome to do so. If I pulled that 2 out front, then I'd have 2 thirds square root of x cubed, which would be 2 thirds square root of 4 cubed minus square root of 1 cubed. Okay, which would give me 2 thirds. Square root of 4 is 2. 2 cubed is 8. Square root of 1 is 1. 1 cubed is 1. 8 minus 1 is 7. And 2 thirds times 7 still gives you that same value of 14 thirds. So just be aware that that's an option for you. And if you're solving these, sometimes it makes it easier, sometimes it doesn't. It's just kind of a personal preference thing. Just be aware that you can do that if you want. All right, that's it for today. Study hard for this test tomorrow and do your best. Talk to you guys later. 2 chains. Bye.